Hello everybody, welcome back to my channel. Today I am going to describe about the introduction to the calculus, right? So let's talk about it. Calculus is a broad and wide topic of mathematics that was introduced to us by Sir Isaac Newton. So let's talk about it. So calculus can be broadly classified into two groups or two types, that is differentiation and integration, right? So we are going to talk about the differentiation stuff today. So let's get into it. Well, as I told, I'm going to describe you about the differentiation topic today. So what is differentiation? Basically, in mathematical language, if we say we need to differentiate a function of x with respect to x, that is dx of a function of x is defined as the gradient or differentiation or change with respect of the function with respect to x, right? So this is the mathematical definition. So let's talk about its physical significance. Actually, physical significance, not graphical significance, rather. So here is a Cartesian coordinate, as I see the 2D Cartesian coordinate, y-axis, x-axis. So I draw a graph, a curve. So let's take an example of function of x, right? I told about this function. So I'm plotting this function right here, right? This is a function, this is a curve function, some curve function. I took a point in it, a point to the curve, and draw a tangent to it. This is a tangent, right? This is a tangent. So I say, give me the value of the differentiation of the function at this point with respect to x. What will be its value? So basically, differentiation is nothing but the definition of slope or gradient of that very function at that very point. And as you have learned in your class 9 or 10, that 8 or 9, that slope can be defined as m. What is that m? It is tan theta. Tangent of a theta with respect to x-axis can be also defined as algebraically y2 minus y1 by x2 minus x1. That is the points, right? This is change in point, right? This is a flowing point, then this is, and within this point I'm saying, so this is y2, this is y1, this is x1, this is x2, right? So this basic change and this basic change introduce this one. I'm talking about this one, right? This by this, right? Means the I'm sorry, I plotted it in the wrong way. Well, the height, this one, y2 to y1 divided by x1 to x2, the base. So basically it's written right here. Tan's formula is what? Height by base, right? So we can see right here many types of maths domains are merging right here. So here is a trigonometric domain, here is an algebraic domain, right? And we are entering into a calculus domain. What does calculus? This D means this is infinitesimally small. It's very small change. As this triangle is like a point, very small, even smaller than this point. So how you define it? Where this is what the physical meaning of the whole concept of differentiation is, right? Well, let's get deeper into it. Well, I told you about the mathematical significance, the physical significance, and the graphical significance of differentiation. Well, so let's get into the algorithmic viewpoint of the differentiation, or as you say, the formalism that's behind the differentiation. So what is the basic of differentiation? This is the most basic formula of differentiation that will help you in a further studies of differentiation, right? This is the most basic one. So what does it say here? This is a function of x. the function I told you, right? The prior one. This is x square is a curve, you know. X cube is also a curve, right? X is a linear function. It's also a curve with means with or radial curvature equal to 0. You must read it in the optics part, right? Well, so let's talk about it further. So as we see here, the differentiation of x to the power n, this is the power of n, power of x, sorry, and the differentiate with respect to x. What do we get? We get n prefix multiplied to x to the power of n minus 1. This is the most basic formula. You need to understand it better way and memorize it, so that it will help you further in the further calculation of differentiation. In every portion it will be very helpful in a function of functions, in trigonometric differentiations, in infinite series, and many topics. I will be giving some videos in my channel later. Well, let's talk about the thing at hand right now. Well, let's talk about the differentiation of trigonometric functions. So as you can see, I wrote Trigs, and this is a short form of trigonometric functions, right? Well, so as you can see, d dx of sin x is cos x, d dx of sec x is sec x tan x, d dx of tan x is sec square x, dx of cos x is minus sin x, dx of cosec x is minus cos x cot x, and ddx of cot x is minus cos x square x. So you need to understand them and memorize them, so they will help you further in the further calculations of when the higher degree or higher functions will be given to you and will be told that you differentiate them with respect to something, or parametric functions, or function of a function. So this rule I will don't worry about them. I will give videos on them later, but as of now you need to understand them and abide by the rules or the formulas that are being mentioned here, right? So I can share a trick that will help you in the memorization. That as you can see, if you memorize this one side, if you can see, I mentioned a positive sign here and a minus sign here. Why did I do that? As you can see, if we differentiate sin x with respect to x, we get cos x. If we differentiate sec x with respect to x, we get sec x tan x. If we differentiate tan x with respect to x, we get sec square x, right? This is the formats one get in every book. Then we get differentiate cos x, we get minus sin x. We differentiate cos x, we get minus cos x square x, cos x cot x, and if we differentiate cot x, we get minus cos x square x. So can you see an analogy right here? The things, if you memorize this side, are near same in this side. Just sin x cos x is changing minus 1, and sec x differentiate it's sec x tan x, just the cosec x cot x means it has a relation between sec x and tan x, and it has a relation between cosec x and cot x, and you get just the minus sign right here, and this is very done. If you memorize this three will be in handy, right? You don't need to memorize 6 of them. It's a basic analogy. Well, let's move further. Well, let's talk about the Leibniz rule. So what is Leibniz rule? Actually, Leibniz rule is not in your syllabus. It's for higher degree differentiations. You will read in your further classes. But as of class 12, we will read about the degree of 1, right? So if Leibniz rule being given n equal to 1, means n equal to 1 times of differentiation and orders and factorials, you know. So you will know in further classes. But as of now, we talk about the product rule. Actually, product rule and quotient rule is both a part of Leibniz rule. So product rule, we define product rule as when the function is given like a function of x u is multiplied with a function of x v, and told you to differentiate as a whole. How you do it? So first differentiate the first function, multiply with the second function, add it with the differentiation of second function with respect to x, differently with respect to x. You are doing the whole differentiation with respect to x, and then multiply with the first one, right? You can see there is an analogy between them. So this is the product rule. And second, we are talking about the quotient rule. what does the quotient rule means? What does the quotient rule means? The quotient rule is where a function of x, here as you see I wrote that both the u and v are functions of x, right? So when u is given as the numerator and v as the denominator, right? If we differentiate with respect to x, what do we get? We get the differentiation of numerator u, the numerator with respect to x, multiplied with the denominator, minus of denominator differentiation with respect to x, multiplied the numerator, the whole divided by the denominator square, right? This is the format known as the quotient rule. Well, so you can also derive with the help of the product rule. Actually, this is a very special case of the product rule, where is the inverse of it multiplied by it, right? You can derive it by taking in the account of the basic rule that I told you, the prior one, that nx to the power n minus 1. Here the when you will do means the differentiation, it will give you as 1 by v square dot u dx multiplied with u, right? And when you will take this as the numerator, you will get this, right? So well, I will show you that one. Well, as I told you that the quotient rule itself is a special case of the product rule. So how we can define it? So we can write it the ddx of u by v equal to ddx of u multiply 1 by v, reciprocal of v, right? Yeah. So then by applying the product rule, we get d du u by v of dx. We can write the here from here you can see the multiplication, the derivative of first function of x with respect to x, multiply the second function plus first function of x, multiply the derivation of the second function, right? Here is the tricky part, this one. So I did the derivation of it right here. So how did this derivation come? Well, we'll learn it in our later sessions when I will talk you about the function of functions, right? V is itself a function of function, right? And we are doing the derivation of v 1 by v, right? So it itself is a function of some function. So how does it looks, right? We do like this right here. Well, let's talk about y, and I suppose y is 1 by v. Then how does it looks? This is a function in itself. I need to differentiate it with respect to v. Then I can differentiate with respect to x. So this is cancelled and this is dy dx. So I need to multiply a dv dx. I need to multiply this term once more. So I did the differentiation of this with respect to nx to the power n minus 1. I told you right earlier, as you can remember, right? So it came, and as I saw, it's a function of function, so it must be multiplied. So here is multiplied. So I am taking this whole value and substituting right here. So you can see, and then making some adjustment here, right, to make it v square. So I multiplied with v in the numerator, and then v in the denominator to become v square. I'm taking the v square common, and then u du by dx and v is coming here, and here v square is taken, and then dv by dx and u is coming here, and as you can see, it's derived, right? Well, this I had to say. This is for today. Well, that's for today. So if you like the video, do like it, subscribe to the channel and share it with friends. Thank you. And this is the next class video I will be uploading in my channel. So if interested, you can see the function of a functions as I told. So there with a few questions I will do, and this is the things it looks like. If y is a part of function of t is a function of u, then how you can differentiate it, right? So well, that's for today. Thank you for watching.